Okay, so let's say we want to calculate some z-scores for some sentence lengths other than 20, 30, 40, 60, 70, and 80 months. So for some values other than our 1, 2, and 3 standard deviations away from the mean in either direction. So I'm going to just redraw this normal distribution here. So we had a mean of 50, and I'm going to put our 1, 2, and 3 standard deviation tick marks here. So we had a standard deviation of 10. So our 1, 2, and 3 standard deviation tick marks landed at 60, 70, and 80, and at 40, 30, and 20. So let's say I wanted to know something about the probability of sentence length landing between 35 months and 75 months. These are pretty arbitrary numbers. You could do this with anything, but I'm going to use them for this example as we go through and take a look at how to do this. Our first step, as I mentioned on the other slide, is going to be to convert these values into what we call z-scores. And z-scores are going to let us count in standard deviation units and figure out how far away we are from the mean. In other words, how many standard deviations away from our mean of 50 is a score of 75. How many standard deviations away from 50 is a score of 35. And we're going to be filling in z-scores for these values that will describe how many standard deviations away from the mean we are. So our z-score equation looks like this. We're going to be calculating z, and we're going to be plugging in the following things. X, which is our value of interest, mu, which is our mean for our normal distribution, and sigma, which is our standard deviation for a normal distribution. So I'll write these things out as well. So x is our value of interest, mu is our mean of our standard probability distribution or normal distribution, and sigma is our standard deviation of our normal distribution. So we already know two of these values just from having this normal distribution example. So we know that our mean is equal to 50 and our standard deviation is equal to 10. In these sorts of problems, those values will always be given. So when I said before that we define our normal distributions based on our mean and standard deviation, I mean that these are values that will be given to help you know exactly what kind of normal distribution you're looking at. So when calculating a z-score, you're always going to have this and this to start with. The value of interest is simply the value that you want to calculate a z-score for. So one value of interest that we have here in this example is 35 months. So this is our sentences in months. And another value of interest that we're going to calculate a z-score for is 75. So I can calculate my z-score for 35 like this. I'm going to plug in these three values. 35 is my value of interest. 50 is my mean. And 10 is my standard deviation. So again, these z-scores are going to be standardized units. So they'll be counted in the same units each time you calculate them. And they'll describe the distance that we are away from the mean, counting in standard deviations. So if we subtract this, we end up with negative 15 over 10, which comes out to negative 1.5. And that tells us that our score of 50 is exactly negative 1.5 standard deviations away from the mean in a negative direction. And this should make some sense in looking at the graph as well. So we can see we've gone out one standard deviation in a negative direction, and then, oh, look, we went halfway before we hit the line. So we are negative 1.5 standard deviations away from the mean, going in a negative direction at 35 months. So this z-score of negative 1.5, again, describes how many standard deviations we are away from the mean, and it tells us the distance and the direction. So we can calculate a z-score for 75 months as well. Oops. So I'll plug our values into the equation for 75 months. Our mean and standard deviation are still the same. They're still 50 and 10. And now our value of interest is 75. So I'll plug in 75 for x, 50 for mu, and 10 for sigma. And that gives us our equation. So now we've got 25 over 10, and that comes out to 2.5 for our z-score. What this tells us is that here our score of 75 is 2.5 standard deviations away from the mean, going in a positive direction. And we can see that as well if we check out our tick marks. So these are marked off at 1, 2, and 3 standard deviations. And we can see that we've gone out 1, 2, and then 2.5 before we hit the line, standard deviations in a positive direction to get to 75. And these turn into kind of nice, neat numbers, given just the numbers I have in the example of 1.5 and 2.5. But a z-score can tell you, for any value that you might have anywhere on this line, exactly how many standard deviations away from the mean you are. We can also see what happens when we plot these z-scores on that kind of basic normal distribution that I showed before, where we were just showing a mean and standard deviations away from the mean without any units. And so here we've got a normal distribution, and I'm going to give this thing a name in a second, but I'll redraw it first. Where here we're marking out our tick marks, and we're not attaching any numbers to them. We're just saying that this is 1 standard deviation, 2 standard deviations, and 3 standard deviations away from the mean, -1, -2, and -3 standard deviations away from the mean. So for each of these, again, we're counting in standard deviations, so +1 standard deviation, +2 standard deviations, and +3 standard deviations. Here I've just omitted the plus and the sigma, and we're saying that this is 1, 2, and 3 standard deviations away from the mean. But I'll write these down here just as a reminder. So this is the same graph as I had over here on this earlier paper, where here we're counting in 1, 2, and 3 standard deviations away from the mean on either side. And they're just marked off as 1, 2, and 3 on this graph, and -1, -2, and -3 on this graph. Another way that we could describe this distribution is to say that we're counting in z-scores. So a z-score is your distance away from the mean counted in standard deviations. Well, at 1 standard deviation away from the mean, we're at a z-score of 1. At 2 standard deviations away from the mean, we're at a z-score of 2. And at 3 standard deviations away from the mean, we're at a z-score of 3. So this normal distribution that I drew before is also one we could say where these values here of 1, 2, and 3, and -1, -2, and -3 correspond to our z-scores, where each of them tells us the distance that we are away from the mean, but counted in standard deviation units. And what we'll see is that if we plot our z-scores on this graph, they're going to show up in the exact same places that they did on our graph where we were counting in months. So our z-score for 35 was -1.5. And if we draw this line here, we can see that it lands in exactly the same place as it did on this graph above. Oops, let me get all this in the frame here. Let me try again to get all this in the frame here. Okay, slightly better. We can also fill in our line here, and this was for 75 months, and we got a z-score of 2.5. And what we can see is that z equals 2.5. This line also lands in the exact same spot in the graph as our line for 75 months. And in fact, every single thing about these two graphs is completely identical except the units that we're counting in. So in this graph, we're counting in sentence lengths in months. And in this graph, we're counting in z-scores. But the shape of the distributions and the places that we draw our tick marks and the places that we draw our lines are exactly the same in either one. So this one's still -1.5 standard deviations away from the mean. This one is still 2.5 standard deviations away from the mean. And the only difference, again, between these two normal distributions here, between these two graphs, is that in this one, we're counting in months. And so we've marked off our mean of 50 months with 60, 70, and 80, and 40, 30, and 20 as our 1, 2, and 3 standard deviation jumps away from the mean. And in this one, we are counting in these standardized z-score units, where the only thing we're counting in is how many standard deviations we are away from the mean. And here we've got 0 at our center because we're 0 standard deviations away from the mean, and then scores of 1, 2, and 3, and -1, -2, and -3, corresponding to 1, 2, and 3 standard deviations away from the mean, going in either direction. So totally identical graphs, only thing that's changed is our units. It's like converting from feet to inches. And as we will see, and I'll talk about on the slide that I'm going to show when I hop back into the PowerPoint, this type of distribution here is going to have a special name, and that is a standard normal distribution.